Hello students, this is a video on the Bodhee Prep topic tests for quant. The idea of these tests are you do the basic concepts of a topic, and then to ensure that you're able to do questions from that topic in an exam, you will take these tests. With every test, there is a video. The video gives you the basic solutions and a brief analysis of the difficulty level and the kind of time you should have spent on the test. There are more than 200 such topic tests available on our Bodhee Prep Android app. The link for the app is in the description of the video. Make sure you download the app and make the most of these tests. This video is on trigonometry, the third test on this topic. Overall, again, it was an easy to moderate level of difficulty test. About 6 to 7 out of 10 questions should have been done in about 20 minutes for a 95 percentile performance in a actual exam of that level, of this level rather. If we look at the questions, it says cosec theta minus sin theta is m, sec theta minus cos theta is n. We have to find the value of m square n raised to power 2 by 3 into mn square raised to power 2 by 3. Now cosec theta can be written as 1 minus sin theta, 1 upon sin theta minus sin theta is m, and therefore sin theta, this becomes 1 minus sin square theta upon sin theta, which means m becomes 1 minus sin square theta is cos square theta upon sin theta. If we look at n by a similar logic, this will be 1 upon cos theta minus cos theta, 1 minus cos square theta upon cos theta. 1 minus cos square theta is sin square theta. Upon cos theta. So if we find the value of m square n, we will get cos 4 theta upon sin square theta m square into n, sin square theta upon cos theta. So this will give us cos cube theta. This is raised to the power 2 by 3. And therefore this raised to power 2 by 3 will be cube and cube root cancels out. So we will get cos square theta. So here we have cos square theta from the first term. The second term is mn square. So m n square. M is cos square theta upon sin theta. N square will be sin power 4 theta upon cos square theta. Cos square cancel, sin cube. And therefore this will be sin cube theta. By a similar logic as the previous term, if we raise the power 2 by 3, everything goes to the power 2 by 3. Cube and cube root cancel, we will be left with sin square theta. And therefore the second term becomes sin square theta. Cos square theta plus sin square theta is 1. Therefore option B becomes my answer. Moderate level of difficulty. The 2 by 3 might be a little off-putting. But apart from that, not a very difficult question, about 2 minutes to solve. The value of cos 1 degree, 2 degree, cos 3 degree, cos 4 degree, and so on till cos 179 degree. Now, the first instinct is to link 1 and 179 because this is 180 minus 1. But that we do when typically an addition happens or there is a tan value that is being multiplied. So the tan becomes cot using 90. Here, it is a lot easier than all of this. If we write all the terms, there will be a term which will be cos 90 degree in the middle somewhere, going up to cos 179. Now, all of these terms will have some value. Cos 90 is 0. So this will be some value into 0 into some other value. 0 multiplied to anything gives us 0, and therefore the answer to question 2 becomes option C. Easy question. All we have to do is spot cos 90. In a product, one of the values is 0. So the overall product will also be 0. Not more than a minute to solve. Without using trigonometric tables, sin 48 sec 42, cos 48 sec 42. So this will be sin 48 can be written as sin 90 minus 42 sec 42 plus cos 48 can be written as cos 90 minus 42 cosec 42 degree. 90 minus 42 means the first quadrant, so positive. Sine 90 will become cos, so cos 42 into sec 42 plus cos 90 will become sine 42 into cosec 42. We know that cos and sec are inverse of each other, therefore this becomes 1. Cosec is 1 by sine, cancel 1, and therefore the sum becomes 2. Option B. This is an easy question, not more than a minute to solve. Tan 5 degree, tan 25 degree, tan 45 degree. This is a value that we know, tan 65, tan 85. 90, 45 plus 65 is 25 plus 65 is also 90. Tan 5 can be written as 90 minus 85. Tan 25 can be written as tan of 90 minus 65. Tan 45 remains as it is. Tan 65 and 85 remain as it is. This is a product that we're taking. Tan 90, therefore, all of these are angles in the first quadrant, so always positive. 90 minus 85, 90 will make tan as cot. So cot 85, this will become cot 25, cot 65, sorry, because of 90. Tan 45, tan 65, tan 85. Therefore, cot 85, tan 85, cot 85 is 1 by tan. This into this, tan 85 will become 1. Cot 65 into tan 65, cot 65 is 1 by tan 65. So this into this will be 1, and then tan 45. The value of tan 45 is 1. So this product becomes 1. This product becomes 1. This value is 1. 1 into 1 into 1 is nothing but option B, 1. Since all the numbers are in the first angles in the first quadrant, the product will be positive. Again, the question on the easier side, I would say, about a minute and a half to solve. Cos square 5, cos square 10, cos square 41, and so on till cos square 90. So what we'll do is, we'll make pairs of numbers that add up to 90. Cos square 5 plus cos square 85, cos square 10 plus cos square 80, cos square 15 plus cos square 75, cos square 20. Don't have to write all of these, but just to be sure that I don't miss a case, cos square 25 plus cos square, this is 70, this is 65. Cos square 30, cos square 60, cos square 35, cos square 55, cos square 40, cos square 45, cos square 50, and then we'll have cos square 45, to which we can add nothing. And also this last cos square 90 is also not used. So 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 60, 70, 75, 80, 85, 90. These are the terms that we have. Cos square 45 will be 1 upon root 2 whole squared, which is half. Cos square 90 will be 0. Now, if we look at this term here, cos square 5 plus, this can be written as cos square 90 minus 5, 85. 90 minus 5 means cos square 5 plus, this will become sine square 5. And cos square plus 5 plus sine square 5 will be 1. So we'll get a 1 from here. Similarly, a 1 from here, 10. This will become sine square 10. A 1 from here, a 1 from here, here, and here by a similar logic. So 1, 2, 3, 4, 5, 6, 7, 8. Plus we have a half here and a 0. Therefore, the total sum will be 8.5. Option A becomes the answer. I will say it is a moderate to difficult level of question because not all the terms are being treated similarly. There are 8 pairs that are formed and then 2 separate terms. So there is a chance of a mistake happening or missing out on a term. So maybe moderate to difficult and about 2.5 minutes to solve. Value of log 10, log of tan 1 degree plus log of tan 2 degree and so on till log of tan 89 degree. Now log of A plus log of B plus log of C is nothing but log of A into B into C and so on. Also, if you look at tan 1 and tan 89 can be written as tan of 90 minus 1. Tan 90 makes it cot 1. So this can be written as tan 1 into tan 2 into tan 3 and so on till not, the sum has to be 90 till tan 44. Then we will have tan 45 and then tan 46. Tan of 46 will become tan of 90 minus 46. So this will be cot 46. And therefore from here we'll have cot 46, cot 40, tan of 44, cot 44. So basically tan of A is equal to cot of 90 minus A. So here we'll have cot 44, cot 45 and so on till cot 2, cot 1 degree. We are taking the log of this entire product. Now tan 1 into cot 1 is 1, tan 2 into cot 2 is 1, tan 3 into cot 3 is 1, tan 45 into cot 45 is 1, and the value of tan 45 is 1 itself. And therefore this entire product becomes 1. Log of 1 is always 0, hence option B becomes my answer. Moderate level of difficulty, you'll have to make 2 changes here. From there you can solve, but I think the solving time will not be very high because we are looking at just one change that has to happen. Log of sin 1 into log of sin. Now here log terms are being multiplied. So the property of log directly cannot be used. Since it is a product, I will try to get a value of 0. Now we know that sine of 90 degree is equal to 1 and therefore log of sine 90 degree will be equal to log of 1. Log of 1 we know is 0. Now in this and all terms, log sine 1 will give us some value, log of sine 2 will give us some value, but there will be a case where we'll have log sine 90 as well in the product, which will continue on to log sine 179. Now in this entire product, this term is 0. If in the product one of the terms is 0, the entire product becomes 0, and therefore the answer to question 7 becomes option A. In terms of level of difficulty, it's a moderate. Figuring out the 0 term might be a bit of a challenge, and then there is log written as well, but the attempt time will not be very high. Cos 24 plus cos 25, cos 155, cos 204. So cos 24 degree plus cos 25 degree. Now this can be written as cos of 180 minus 25. And this can be written as cos of 180 plus 24. Cos of 24 remains as it is. Cos of 25 remains as it is. 180 minus 25 is second quadrant and cos of 180, so cos will not change. So this becomes minus cos 25. 180 plus 24 is third quadrant. Tan is positive in the third quadrant. Cos is negative. So minus cos 180 means cos will remain cos. So minus cos 24. Cancel, cancel. Where value becomes 0. Option C. Again, I think easy question. We're just putting the values of the angles and solving. Should be able to do it in about a minute and a half. Cos 24, cos 5, cos 300, 175, 204. These two will be related. These two will be related. This will be a separate calculation. So write cos 24 as cos 24, cos 5 is cos 5, not a problem. Cos 300 becomes cos of 360 minus 60. Cos 175 becomes cos of 180 minus 5. Cos 204 becomes cos of 180 plus 24. Cos of 24 remains as it is. Cos of 5 remains as it is. 360 minus 60 is fourth quadrant. Cos is positive, so cos 60. Because of 360, cos will not change. 180 minus 5 is second quadrant. Cos will be negative. 180, therefore cos will not change, so minus cos 5. 180 plus 24, third quadrant. Cos will be negative. Because of 180, cos will not change, so minus cos 24. Cancel, cancel. Cos 60. Cos 60 we know is 1 by 2, and therefore option C becomes our answer. Again, moderate level of difficulty because of the fifth term I'm saying, but definitely solvable in less than 2 minutes. Sine square theta is equal to x plus y whole square upon 4xy. This is possible when x and y are greater than 0 x is not equal to y, x y greater than 0, x is equal to y, x greater than 0, y less than 0, or none of these. Now, if we look at the right hand side here, x plus y whole square upon 4xy. Suppose this is equal to a. Now what I'm doing, I'm taking 1 by 4 in the side. This is x plus y whole square upon root of xy whole square. Basically, if we put xy in the root, we'll have a square outside. So the entire thing can be put as a square. So this becomes a. So 1 by 4. Now this can be written as x upon root of x root of y plus y upon root of x root of y. This is a square of this. So 1 by 4 into this will become root of x upon root of y plus root of y upon root of x. This is equal to a, the square of this. Now if you look at this term here, am is greater than equal to gm. So root of x plus root of y plus root of y upon root of x upon 2 am is greater than equal to under root of x upon root of y into root of y upon root of x, which will come out to 1. And therefore, we can say that root of x plus root of y plus root of y plus root of x has to be greater than equal to 2. Therefore, the square of it has to be greater than equal to 2 square. So this term has to be greater than equal to root of x upon root of y plus root of y upon root of x whole square has to be greater than equal to 4. Therefore, 1 by 4 of this has to be greater than equal to 1, which means a is greater than equal to 1. Also, if we look at sine theta, we know that sine square theta will lie between 1 and 0. Because sine theta lies between -1 and 1. If we square, all the values become positive, but it will not cross 1. The only common value for a and sine square theta is when the value is 1. And therefore, sine theta has to be equal to 1 is what we get, or this has to be equal to 1. When will this be equal to 1? X plus y whole square is equal to 4xy. If this has to be 1, that means x square plus y square plus 2xy is equal to 4xy, which means x square plus y square minus 2xy is equal to 0, which means x minus y whole square is equal to 0, which further means that x minus y is 0 or x is equal to y. So the only possibility for this to be true is when x and y are positive, so that this is positive, this remains positive. But more importantly, x is equal to y becomes my answer. I'd say this is probably a difficult question in terms of, or with respect to other questions. About 2 minutes to solve. So we will look at the overall test. About 20 minutes for 6 to 7 questions. For me, these questions will be 2, 3, 4, 6, 7, 8, 9, which are the. I am not counting this directly because again, the powers could be a little frightening. So not a sure shot question for me. Definitely doing this angle based. Definitely doing this one angle based. Again, this is also angle based. Here there was probably the pattern was not complete or cyclical, so might miss out on a point here or there. This was, I think, straightforward. A similar question on similar lines should have been done. 8 and 9, both of them, I think, were basic questions of putting angle value should have been attempted. This question, I'd say, was a little difficult. May not be something that I'll do in the exam every time. And therefore, for me, 2, 3, 4, 6, 7, 8, 9 become my attempt questions.